Hello everyone, welcome back to SmartPath Tutoring. This video is on GCSE Physics, specifically on transformers. Transformers change the potential difference, but only for an alternating current. Transformers change the size of the potential difference of an alternating current. They all have two coils of wire, the primary and the secondary, joined with an iron core. With an alternating potential difference applied across the primary coil, the iron core magnetizes and demagnetizes quickly. This changing magnetic field induces an alternating potential difference in the secondary coil. If the second coil is part of the complete circuit, this causes a current to be induced. The ratio between the primary and secondary potential differences is the same as the ratio between the number of turns in the primary and secondary coils. Step-up transformers. Step-up transformers increase the potential difference. They have more turns on the secondary coil than the primary coil. The step-down transformers reduce the potential difference and they have fewer turns on the secondary coil than the primary coil. The transformer equation. Use it either way. As long as you know the input to potential difference and the number of turns on each coil, you can calculate the output potential difference from a transformer using the transformer equation below. This transformer equation is Vp, which is the input potential difference, over Vs, which is the output potential difference, equals Np, which is the number of turns on primary coil, and Ns, which is the number of turns on the secondary coil. The key points that you need to know are: number one, you need to be able to relate both of these equations to power transmission in the national grid to explain why and how the national grid transmits at very high potential difference. Number two, you've already seen that a low current means that less energy is wasted heating the wires and the surroundings, making the national grid an efficient way of transmitting power. The equation above shows the why, and for given power, a high potential difference is needed for a low current. Now, number three, the equation is the one big reason that we can use low voltages in the home, but then step up the potential difference and decrease the current to the high voltages used on the national grid. That's the end of the video. I hope that you all enjoyed. Don't forget to like and subscribe.